Hello, welcome to my channel. We will be doing question number 11 today. Okay, so if we need to understand this whole geometry, we have a cone, inverted cone, and inside the cone we have a cylinder. And the diagram shown over here is a cross section of this whole arrangement. Okay, so you can see that uh, this is my cylinder, the top of the cylinder, and this is the height of the cylinder. So this one, yes, this is a similar triangle with this bigger triangle, right? Am I right? These two triangles, the bigger triangle and the smaller triangle, they are similar to each other. Okay, so if they are similar, let me erase whatever I drew. If they are similar, then the ratio of this side to the bigger side is same as the ratio of this one to the bigger side. Okay, hope you are okay with what I'm saying. So let's try to do part one. Okay, so you can see that this smaller side, this is simply 6 minus r, because r is the radius, okay, and total width is 6. So 6 minus r divided by 6. So whatever is the ratio between this and 6 is equal to, okay, now this smaller is h, and divided by the whole height is 8. Okay, I hope you understand what I'm doing. So since I have two triangles, again, let me draw them over here. My triangle is not good over here. Okay, so if I have two triangles, okay, so one is smaller triangle and one is the bigger triangle. So the ratio of this to this is same as this to this. This is what I have done. Okay, so this is express h in terms. Okay, so you can see that h is equal to 8 by 6 into 6 minus r. Or I can say it is 4 by 3 into 6 minus r. So this is my part 1. So let's do part 2 now. Okay, part 2 hence show that the volume of the cylinder is given by this expression. Okay, the volume of cylinder is easy. We need to calculate the volume. So what we will do, we will find the base area into the height, right? Okay, now base area is a circle. The base is a circle, so the area is pi r square. And when I multiply it with the height, which is h, it will give me the volume of the cylinder. But I want to express in terms of r only. Okay, you see, there is r only, there is no h here. So what I will do, I will replace this h by this expression. So this is 4 by 3 into 6 minus r. Okay, so it will become pi r square into the 8 into 8 and minus 4 by 3 by r cube. This r into r will become r cube. So let me write down it's again, it's 8 pi r square minus 4 by 3 pi r cube. Okay, this is what it says here. Okay, so this was part 2. Now let's go to the part 3 of this problem. Part 3 says, given that r can vary, find the value of r, which gives the stationary value of v. Find this stationary value of v in terms of pi and determine its nature. Okay, so let's try to find dv by dr in order to find the stationary point. So this is going to be 16 pi r minus 4 pi r square. Okay, hope everybody follows me what we are doing. Okay, so when I make it equal to 0 and solve it for r. Okay, so r, if I take common, it will become 16 pi minus 4 pi r, and this is equal to 0. So one solution is that r is equal to 0. Of course, we will not buy this solution. Okay, The second one is 16 pi is equal to 4 pi r. And from here, r is equal to 16 pi over 4 pi. So it will give you 4 only. So value of the stationary point at the stationary point r is 4. Okay, and show that the volume is okay. Sorry, given that the R can find the value of R, which gives the stationary value of P, find this stationary value of P. Okay, now at this value of R, let's try to find the volume of the cylinder. Now, volume of the cylinder we know it is uh, pi. Sorry, 8 pi R square minus 4 by 3 pi R cube. So it will become 8 pi and 4 square is 16 minus 4 by 3 pi and 4 power 3 is 64. And when I simplify all of this, it gives me, what did it give me? 128 pi by 3. Okay, so many cubic centimeter. And this was 4 centimeter, sorry. Oh, yeah, 4 centimeter. This is the answer for the R. Okay, given that R will find this stationary value of P into the pi and determine its nature. Okay, in order to find the nature, we need to find the second derivative. Okay, because okay, we know that the stationary values when R is 4, but is it giving us the maximum volume or the minimum volume? Right, this is the question. Okay, so in order to find the nature, we need to differentiate it second time. So d, sorry, dv square by d, sorry, yeah, it is d square v by d r square. Okay, okay, so it's the second derivative. Second derivative from here, it is going to be 16 pi minus 8 pi r. Okay. Now, what is the value of the second derivative? By r square at r equal to 4. Remember, r was 4. So, it is 16 pi minus, if r is 4, it's going to be 32 pi. So 16 pi minus 32 pi is minus 16 pi, which is a negative number. And whenever the second derivative is negative, it means this is the maximum point. So this is the maximum value. So when R is 4, we will get the maximum volume of this cylinder. Okay, hope you enjoy this presentation. If you have any question, you can always ask in the comment section. See you in the next video.